This question reads, let me make it a little bigger here. A recent national report states the marital status distribution of the male population age 18 or older is as follows. This is guys in America, male population, right? National report, so it's America. Never married, 31%, married, 56.6, widowed, 2.1, divorced, 10.3. The table below shows the results of a random sample of 1,876 adult men from California. This is a California man. Test the claim that the distribution from California is the same as the distribution for the whole nation at the alpha 0.01 significance level. So that's what we're trying to test. Is it the same? Is it exactly the same? So in other words, is the men of the nation, national report, right? All America, these percentages, are they the same as the California men, basically? Or do the California men numbers fit the national men, or are California men different? So how are we going to do that? What kind of test is that? Well, we're asking if these percentages, I'll write them in over here, 31% never married, married, 56.6%. This is for national. It's for the whole nation. And 2.1% and 10.3%. So we're wondering if those men for the whole nation, do that fit with the California numbers? So we're wondering if these two things fit, aren't we? Right? So they say that testing the distribution of color is the same distribution. So whenever you're trying to match up some fixed percentages, what is that? Let's go back to the notes. That's goodness of fit. See, there's two kinds of goodness of fit. There's equal distribution or same frequency, like in other words, all the categories the same. That's not going to be, there's not the same number of married men as widowed men as divorced men. They're not all the same. But there's another one, category percentages listed. That's what we have. We have category percentages being listed. So what do? You do goodness of fit test. Do a goodness of fit test. So we're going to do that. And so on our calculator, we're going to need to go there. So the first thing they're asking us is what kind of what's the appropriate test? Goodness of fit test. And by the way, if you don't have that on your calculator, then if you have a TI-83, so the goodness of fit test is only on the TI-84. So if you have a TI-83, there's a program that you need to enter yourself. It only takes about 10 minutes. And it's at the top of the question, there's a link. So as you see the question on the computer, right up here at the top, right above these words, I cut it off, but there'll be a link to get that program. That's if you have a TI-83. But if you have a TI-84, which most people have, then you've already got the program. If you have a TI-83, then you need to click that link up here and get the program before there's a link on the question. When you do it on the computer, you'll see a link up there to get the program. All right, that's for the TI-83. But if you have a TI-84, you've already got the program. Let's go on. So goodness of fit test. What's HO and H1? Well, for goodness of fit, this is the exam 4 notes. HO is observed and expected to fit well. H1 is they do not fit well. HO they fit, H1 they don't fit. So HO is right there. Same as it is nationally. California is the same. And H1, California not the same. Right? Yeah, same, not same. So there we go. That's just like, what is HO always? HO is always equal, huh? And equal is same. And H1 is not equal, not the same. That's really nothing new, right? It's the same kind of thing we've been doing all along, all semester long. HO has been equal or same. H1 is not equal, not same. That's what we're trying to do. Is the distribution of California men, does it fit the percentages for the nation? That's what we're trying to answer. All right, next. We need to get the test statistic. There it is from our calculator. So I'm going to show the steps on the calculator. They're up here. Goodness of fit. You basically, on the TI-84, you need to go to stat, test, X squared, goodness of fit test, observed L1, expected L2, da-da-da-da-da. On the TI-83, you use the program, chi-squared goodness of fit. But notice it's referencing L1 and L2. So first we have to put the data, yeah, it says it up here, huh? Put the observed values in L1, calculate expected values in L2. So put observed values in L1. So I'm going to put the observed values in L1. So L1, in other words, is going to be these observed values, because that's what we saw. That's what's observed. We saw that men in California, 578 were never married. You know, just looking at the categories: never married, married, widowed, divorced. So we observed that. Now, in L2, we're supposed to calculate the expected, is what it says. Right, going back to the notes. Right? Put the observed values in L1 and calculate the expected values. Now, how do you do that? Well, for category percentages like we have right now, you need to take each category percentage times the total number of values. So each category percentage, so 0.31 times the total. What's the total number of values? Right here, total. 1876. There's 1876 men in this study. Total study, California men, 1876. Next category, 0.566. See, I'm moving the decimal back 2 places like we always do. We take a percentage and change it to a decimal. This one, watch out, 0.021. This one, 0.103. So that's what I'm going to type in to my calculator. Exactly that. Put those in L1 and L2. And then you're going to have to quit that, hit second, and the mode button, which has quit above it, like that. So it's kind of like, here's step number 1, here's step number 2, step number 3 is going to be stat, this stuff right here. Oh, and degrees of freedom, it's going to be number of categories, which is going to be 4 minus 1, or 3, because we have 4 categories here. So let's go back. So we're going to go to the calculator at that point. We're going to hit stat, like that. Go over to tests. And go down, way down to, it'll be D, or the X squared or chi-squared. It's actually a Greek letter. GOF test, goodness of fit test. Again, this is on the TI. This is only on the TI-84. If you have a TI-83, you won't have that. The TI-83, you're going to enter the program. First, as I said, first enter GOF program using video link. I'm getting kind of scribbly here. Using video link at the top. So at the top of the problem, you'll see a video link. Put that program in, and then for the TI-83, you'll just hit program goodness of fit, chi goodness of fit, enter. So I'll say TI-83, you'll hit PRGM button, which is right in the middle of the top, PRGM button. And you'll choose the CI chi-squared goodness of fit, and you'll hit enter. So that's what the TI-83, after you first have to enter that program using the link at the top. All right, so once you get that in there, then it's going to ask you, so here, I'll do that too. It's going to ask you, at least on the 83, it'll ask you step 4 here now. It'll say, okay, what is observed? What is expected? Observed and expected have to be L1 and L2. You know how to do that. We've done that before. Got to hit second L1, second L2, L1, L2. Degrees of freedom, DF. That's going to be 3. How did we get that? 4 categories minus 1. So you take the number of categories, see it up here in the notes. Degrees of freedom is the number of categories minus 1. How many categories do we have here? Well, 4 categories, right? 4 categories. Never married, married, widowed, divorced. 4 categories minus 1 is 3. Degrees of freedom is 3. And then just calculate. And you'll get your numbers. Calculate. Hit enter. And you get your numbers, and you'll get, there's your test statistic. There's your p-value. I'm going to show those right now. Okay. So I'm going to go to L1. I'm going to go stat, edit, get up here. I'm going to have to clear out L2 from what I was doing before. Clear out L1. Now I'm going to put the data. Write down L1. So that's going to be, what's it, 578. These are the observed values. 1083. And then 19. And 196. Enter. Now on the other side, L2, I'm going to put those calculations. I'm just going to type in those exact calculations that I showed you on the screen. 0.31 times, what is it, 1876, the total number? Because that's what we're expecting, right? If these really fit, if California men are just like national men, then we would expect if we interviewed 1,876 California men, 31% of them would be whatever that first category was, never married. So I took 0.31 times the 1876. And the next category is married. Well, in the nation, 56.6% of men are married. So that'd be 0.566 times 56.6% of the 1876 men that we interviewed in California. If they're the same as the nation, we should have whatever that comes out to be, about 1061. Are they fitting pretty well? Yeah, not bad. They seem like they're pretty close to what we expect, right? Because this is what, see, the L1 is what we observed, it's what we actually saw when we interviewed 1,876 men in California. And over here on L2 is what we expect if California is just like the nation. We expect to have the percentages. So the next was 2.1%, 0.021, right? Remember to move that decimal back 2 places, 0.021 times, right? 2.1% of the 1876 men. So I'm typing that formula in. So I'm just typing a formula in for every box in L2. I'm typing in a formula, hitting enter. We'd expect it to have 39 point whatever, about 39 of the men. We actually had 19 of the men. That one's off a little bit, I guess. Fourth category, 10.3%, so 0.103, change to decimal, times 1876 men, 1876 men. Enter. We'd expect about 190. You know, if California is matching the nation, then we'd expect, right, the same percentage, 10.3%, 0.103 times the 1876 men, 10.3% of times the 1876 men. We'd expect that many men in the California survey. And what we actually observe, pretty close. So those numbers are pretty close, aren't they? Pretty darn close. Okay, so now we go second, quit, right? We get the blue, quit to get out of that mode. And then we're going to go stat. I'm going to go over here and go way, way down to D, at least on the TI. I have a TI 84. If you have an 83, again, you'll do something a little different as I wrote out. Chi-squared, goodness of fit test. X-squared, goodness of fit test. You go hit enter. And it says, okay, observed, expected. Well, the observed values are no enough. These were empty. If these were clear, I'll just clear it. You would have to go second one to put in L1. And then L2, if there's nothing there, you'd have to go second 2 to put in L2. Degrees of freedom, I've already got the 3 in there because that's the number of categories minus 1. Go down to calculate, enter. There's our x-squared number, which is exactly what we saw on the screen, and our p-value. There they are. Let's go back to our screen. And so now we will shift back to this screen and finish up this question. And so here we go. And then, so now, so here is the test statistic that we got from the calculator and the p-value. So now we're ready to conclude. Is that p-value, which is 0.0115, how does that compare to the alpha level? What is our alpha level? Our alpha level, going back up here, I don't remember. Oh, it looks like it's kind of hidden right here. Come on, alpha 0.01 right there. Alpha is 0.01, 0.01. So our number is just a little bit bigger, isn't it? 0115 is a little bigger than 01. So bigger, right? So so what does it mean when it's bigger? Well, if you're unsure on that, if you're like, I'm a little rusty, what does that mean? Here, I'll show you the exam 3 notes. You can always go back to the exam 3 notes because that has the information. Here it is. So this is the exam, even though we're on exam 4 material right now. Exam 3 notes, this shows, here's the conclusions. Here's the conclusions depending on whether it's less than or greater than. What is ours? Getting back here, the p-value is greater. P-value is greater. So if we go back and say, oh, we're right here. P-value is greater than alpha. Then we're going to be here. So what's that mean? Fail to reject HO. Keep HO, weak evidence. So go back and go, oh, okay. Fail to reject HO, just like it says. Keep HO and weak evidence. It doesn't have us put that in anywhere. I'll just write it. Weak evidence. Now, keep HO. What does that mean? Well, we got to go back and remember HO and H1 are the two attorneys that are arguing. Here's HO and what he's saying, and here's H1 and what he's saying. We're looking at the evidence, deciding who we believe. What does HO say? The distribution is the same. Oh, sorry, is not the same. Wait. Did I click the wrong one there? I did. Look at that. I should be a little more careful. HO is this one, the same. H1 is not the same. So HO is same. HO is always same. So HO is same. Sorry about that mistake there. HO is same. And that's who we believe. HO, right? HO said, I'll just write it right here. Same. H1 said not the same. Well, our evidence said keep HO. Keep HO, which means they are what? The same. We believe the California men and the men for the whole nation, their marriage, their different categories of married, widowed, divorced, and stuff are pretty much the same. Because the evidence is weak. There's just not enough evidence to show they're different. Pretty much the same. So weak. Now, which one of these mean weak evidence? Weak, remember, is insufficient. If something is weak, it's not enough. That's insufficient. Sufficient means enough. So insufficient means not enough. Like if you write a check, if I wrote a check for $1 million to you, the bank would say, Mr. Heron has insufficient funds because I don't have $1 million in the bank. So it'd be a bad check. They could say insufficient, not enough money in the bank to really cash that check. So insufficient means not enough, like weak. Weak evidence means insufficient. So it's going to be one of these insufficient ones, this one or this one. Which one? Insufficient to conclude that they're dependent? No, we're not talking about dependent. Insufficient to conclude that it's not the same. Yeah, that's right, as it says down here. Insufficient to conclude it's not the same, right? There was not enough evidence to conclude they're not the same. So we concluded they're the same. I know that's a little confusing. It'd be like if I said, I'm not going to not go there, which means I am going to go there, right? I know it's confusing. Insufficient means not. If there's insufficient evidence, then there's not enough evidence, right? And there wasn't enough. There was not enough evidence to conclude that they're not the same. So we conclude they are the same. There wasn't enough evidence to show they're not the same. So then they are the same, which was our conclusion. Let me say that one more time. I know that's confusing. So in the end, we knew it was weak, which is insufficient. So we knew it had to be one of these two insufficient ones. It's not any of the sufficient ones, right? So then we're down to those two. Remember, whenever they say insufficient, that means not the same. So that is the same, which is what we said. We keep HO, and HO said same. So that's right. There was not enough evidence to say H1, not same. So we stuck with HO. Not enough evidence to say not same. So we go with same, HO. That's right. And so there we go.